This is section 3.5. In this section, we're going to be solving equations and inequalities that have absolute value on them. Okay, so let's just begin with the idea of absolute value. Absolute value, what it's doing is it's one-dimensional distance. So one dimension, imagine that you're just on the number line, on the real number line. To say that the absolute value of x equals 5, well, what that is actually asking is, can you find some points on the number line that are a distance 5 from the origin? That's what the absolute value is alluding to. It's distance from the origin on one dimension, on the number line. So how far away you are from 0. So, well, there are two numbers that are 5 units away from 0. One of them is 5 and the other one is negative 5. So the absolute value of 5 equals, so yeah, the absolute value of x equals 5 has two solutions, negative 5 and positive 5. Those are the two numbers that are a distance 5 away from 0. And you can sort of see here the illustration. So 5 is 5 units away from 0. Negative 5 is also 5 units away from 0. Now, if you were to ask the question, what's the absolute value? So imagine this equation right here. The absolute value of x equals negative 12. Well, that has no solution. Why? Because distance cannot be negative. You cannot be a distance of negative 12 from 0. That would make no sense. Distance is always positive. So distance is always positive. That's why the absolute value makes things positive. So we're gonna start solving absolute value equations here in a second, and that's, I mean, our guideline for solving absolute value equations is going to be that, well, if the absolute value of x equals a, that's equivalent to just x equals a or x equals negative a. Now we're also going to be dealing with inequalities. And these little illustrations here of inequalities, so the absolute value of x is bigger than 2, means that all things that are bigger than 2 and less than negative 2, the absolute value of x is bigger than, well, that would just be brackets. The absolute value of x is less than 2 are things, well, that are less than 2 and bigger than negative 2. So we'll come back to this stuff once we start solving inequalities. So let's try to solve some equations first. Let's try to solve some absolute value equations. Okay, let's get into this first little examples here. So let me try to help you solve this one. The absolute value of x equals 3. All right, so what that is asking is what numbers on the number line are 3 units away from 0? And well, there are two, negative 3 and positive 3. So I guess this just kind of breaks up into two equations, x equals 3 or x equals negative 3. And those are my solutions. This one over here, it might look a little tricky here. I mean, literally what happens here is that you have x equals negative 3 or x equals negative 3. And the negative, well, that just becomes positive 3. And it's as easy as that, at least in these two particular examples. Alright, so let's get into some examples that are a little bit more challenging. They give us a little bit of instructions on how to tackle absolute value equations. So the first thing is that, so if you're trying to solve an absolute value equation, first isolate the absolute value part. So leave it all by itself on one side of the equation. Even if you had multiple absolute values, try to isolate one of them. Next is you apply the absolute value property. That's this thing that we were talking about, that you split the absolute value equation into two equations that do not have absolute values. Like this equation, this absolute value equation, absolute value of x equals 3, that's split up into two simpler equations without absolute value. That's what the absolute value property is. And then you solve each one of the simpler equations. Okay, so let's have you practice some of these things. Pause the video at this point and solve these 4 inequalities. Try to get answers to these 4 inequalities. All right, so I hope that you pause the video and that you have answers, and let's compare answers and let's just kind of compare our work. Okay, so for the first one, part A, the absolute value part is already isolated. It's already on the left hand side, so that's great. So step one, it's kind of already taken care of. So let me apply the absolute value property here. So what I can say here is that this is going to become 3x plus 5 equals 14. And the other equation that I should get is 3x plus 5 equals negative 14. And now I gotta solve each one of these equations. So the first one, well, I have to subtract 5 from both sides. So that's 3x equals 14 minus 5. That's 9. And then divide by 3. So x equals 3. Over here I have to subtract 5 from both sides. So this would say 3x equals, and now I would have to think negative 14 minus 5, that's negative 19. And then I have to divide everything by 3. So x is equal to negative 19 over 3. Okay. And those are my answers. Those are my answers. And I mean, if you're doubtful, you can always check your work too. Yeah, you can always check your work. I'm going to show you just a little trick here. Using the calculator. How can you use your calculator to solve this type of an equation? So graphically, what's going on here? What we could do is let me just kind of erase some things that I have here. Okay, so I'm going to try to get solutions to this equation by using my calculator. So what I'm going to do is I'm going to think of two equations. One equation is going to be y equals the left hand side, the part with the absolute value, and then the other equation is going to be y equals the right hand side of the equation. So I'm going to do absolute value of 3x plus 5. That's what I want to enter here in my first equation in my calculator. To find the absolute value, I'm going to go to math. So second, where's math? Let's look for, there's a button that's right there, math. I'm gonna go to number, and then I want abs, that's absolute value. So absolute value, 3x plus 5. Oops. Did I enter? No. Sorry, technical difficulties. So 3x plus 5. Let's enter that again. So 3x plus 5. So that's my first equation. I'm gonna hit enter. My other equation is just 14. Okay, now I'm gonna look at the graph of these things. So that's my absolute value equation. My other equation, y equals 14, we cannot see it right now because my y-axis goes from negative 10 to positive 10. And well, 14 is above here, up here, and I cannot see it. So I'm gonna change my window a little bit. I wanna make my y's go from, I don't know, let's say negative, actually I only need to go from 0. I should just go to from 0. So oops, so we had our graph. We don't see the full picture, but we want to change the window, we said. So the y minimum, I'm going to change it to 0. And the y maximum, I'm going to change it to, I don't know, let's do 20. Now let's look at the graph. So that's my absolute value part. Y equals the absolute value. The other one's y equals 14. And right now, what this equation is asking is, where do these two graphs intersect? Yeah? And if you remember, your calculator has the capability to find the points of intersection. So I want to find the x-coordinate of this point, and I want to find the x-coordinate of that point. So let's see. Let's find the left point of intersection. So I'm going to do second, calc. I'm going to go to intersect, and right now what you want is this little option up here, calc. So I'm going to go to intersect. I'm going to move my cursor. There's a little like cursor that pops up on your calculator when you're doing this, And right now I'm following the first curve to where I think the point of intersection is. And I think the point of intersection is right around there, so I'm gonna hit enter. Now I'm on the second curve, the horizontal line. And again, I need to move my cursor to where I think the point of intersection is. So I think it's also right around there. I'm gonna hit enter. And that gives me negative 6.333333. Okay? Was that one of the solutions that we found earlier when we did it by hand? Well, turns out, let me get out of here. So we found this solution, negative 19 over 3. Negative 19 over 3. So let's see, negative 19 divided by 3 turns out is negative 6.333333. So that's this solution right here. That's the leftmost solution. Now let me find the rightmost in point of intersection. So we said second calc, and what we want is intersect. Enter. So let me follow the first curve to where I think the second point of intersection is. I think it's right around here. I'm gonna hit enter. I think now I'm in the second curve, and I think the point of intersection is also around there, so enter. Now let's just hit enter. And my calculator has computed that the point of the x coordinate of the point of intersection is 3, which is what we found. So this would be another way of just checking your work. Yeah. If you like it, good, use it. If you don't, then I think sometimes by hand actually is a little bit easier. It's a little bit faster. Okay, so let's solve the other ones. Let me solve part B. So on part B, what I'm going to do is I'm going to subtract 8 from both sides. And then I'm going to do, okay, so then absolute value of x minus 3 is equal to negative 4. Yeah, that was the first step. I needed to isolate the absolute value. Okay, and now I'm dealing with this equation here. And here I'm going to put a little warning here. Here it kind of gets tricky. I'm going to say this is a tricky part right here. Why is this tricky? Because if I just kept on going with the flow of things, I would apply the absolute value property and split this equation into two equations. But then that would be a mistake. That would be a mistake. I would end up with weird solutions that actually make no sense. And why is that? My suggestion to you is anytime that you have either an equation or an inequality that has absolute value, and so you have something like absolute value and then an equation or an inequality, and then you have a negative on the other side, you want to be careful. It's a tricky situation. Why? Because you gotta remember that the absolute value stuff is always positive. Absolute value is always positive. And so then that means that it's always going to be above the x-axis. Whereas negative 4, y equals negative 4, well, that's below the x-axis. And so then these two graphs will never intersect. And so right now, what I'm going to conclude here is that this has no solution. And why is that? This is actually no solution. Let me use my calculator to see what's going on here. All right, so let's see. Why is it that this has no solution? So I'm going to go to y equals. Again, let me clear this. We said that on the left-hand side, I'm just going to enter the absolute value of x minus 3. So we said math. We go to number. We go to absolute value. And then we're going to enter x minus 3. All right. And then in the second line, we're going to enter negative 4. All right. Let's graph this. And now I gotta change my window again because I had to change it just a second ago. Let me go to here to the what's called. So I hit zoom, and then there's this option here, an option here called Z standard. The Z standard option, that's just your regular window that goes from negative 10 to 10 on both the x and y axis. So I'm gonna go to just the standard window. You can. This is kind of a shortcut so that you don't have to manually change the x coordinate. The negative x coordinate, the positive y x coordinate, negative y coordinate, positive y coordinate. So that's Z standard. That puts me on my regular window. And what you can see here is that this curve, or that the absolute value part, will never intersect the line y equals -4. That's why this has no solution. Yeah? So if you found solutions to this, they are not real solutions. So just be careful. Anytime that you have an absolute value and then an equals or an inequality and then you have something negative on the other side, you should just pause for a second and remind yourself the absolute value part should always be positive. Okay, so let's solve the third one. So for the third one, I have the absolute value of 2x minus 1 equals, if I add 5 to both sides, then I would have -3 plus 5, and that's 2. Alright, this is not a tricky situation. This is okay, because it's positive over here. So this splits up into two equations. One of them says 2x minus 1 equals 2, and the other equation says 2x minus 1 equals -2. And now I gotta solve each one of these equations. So let me add 1 to both sides. So that would say 2x equals 3. And then x equals 3 over 2 after I divide by 2. Here if I add 1 to both sides, this would say 2x equals -1. And then x equals -1/2. And those are my answers. We could verify that these are the correct answers by putting things into our calculator, but they are the correct answers here. All right, the last one. So in the last one, I'm going to subtract a 5 first from both sides. So then that leaves me negative absolute value of 4x plus 3 equals -3. And then if you're thinking, oh, wait a minute, we have a negative here, this is a tricky situation. No, well, there's this negative in front of my absolute value. Technically, it's a -1, and I want to get rid of it because I need to isolate the absolute value part. So right now there's a -1 multiplying the absolute value. So how do I get rid of that? I guess I have to divide everything by -1. So let me divide everything, both sides, by -1. Divide the other side by -1. Well, then that would say absolute value of 4x plus 3 equals +3. And that's okay. We know how to proceed from here. This breaks up into two equations, one of them being 4x plus 3 equals 3, and the other one should be 4x plus 3 equals -3. And now we gotta solve each one of these little equations. So this would say 4x equals 0 because I have to subtract 3, and this other equation would say 4x equals -6 because I have to subtract 3, and -3 minus 3 is -6. Okay, so then this would say x equals 0 because I have to divide by 4, and 0 divided by 4 is 0. Over here I would have x equals -6/4, which is the same thing as -3 over 2, -1.5. Okay, so that is what we got. And now if we wanted to verify this and just kind of practice with our calculator here a little bit, we can certainly do that. Then let's just check what's going on here. So let me just clear everything that I entered. So on the first equation that I'm going to enter is 5 minus the absolute value of 4x minus 3, 4x minus 3, okay, so it's not minus 3, plus 3, let's change that to a plus 3, alright, enter. The other equation should just be 2. Okay, let's look at the graph. Let's look at the graph of this situation. So that's my absolute value part, that's my y equals 2, and turns out that one point of intersection is -1.5 when x is equal to -1.5. That would be the left point of intersection. The right point of intersection is right at the y-axis. That's when x is equal to 0. So it looks like my answers make sense. Alright, So that is it for solving absolute value equations. Just keep in mind, and this is actually true for the next examples that we're going to do here in a second, that if you have absolute value and then you either have a equals or an inequality, and then on the other side you have something negative, you are dealing with some kind of tricky business. So be careful. All right, next thing. Let's solve absolute value inequalities. Let's solve some absolute value inequalities. And the guidelines that we're going to use for this absolute value inequalities are the following. So if you have the absolute value of x, or the absolute value of x less than whatever a is, let's just assume that a is positive, then that's equivalent to saying to the following inequalities, that x is less than a and x is bigger than negative a. And this can be written either as a compound inequality like this, x is less than a, that's the right part, and then x is bigger than negative a. Remember that this little symbol here on the left, this one is less than, and this, is less than, I guess this one is also less than. It's just kind of, with inequalities, it can get confusing because we're so used to reading things left to right. So if you were to sort of ignore this symbol and this a over here on the right part, this would mean that negative a is smaller than x. Now if you ignore this part on the left, then it would say that x is smaller than a. Yeah, so this compound inequality can also be written as x is less than a and x is bigger than negative a. So this is how we're going to be dealing with anytime that we have a less than. If you have that the absolute value of x is bigger than a, that's equivalent to saying that x is bigger than a or x is less than negative a. And the same statements are true if you had less than or equal or bigger than or equal. You would just change this inequalities to less than or equal or bigger than or equal. So this symbol right here, this one you say less than, and it corresponds to and. This one is bigger than, yeah? So let me just kind of write that down because, I don't know, so this one's going to be less than. This guy over here is greater than. That's of course if we are reading from left to right, but sometimes you have to read things from right to left, and then, well, things just change. Less than corresponds to and, which means intersection. Greater than corresponds to or, which means union. So intersection, you can also think of overlap. All right, let's see if we can put these ideas to work. I think this little property here might get a little bit confusing, but once you start using it, you'll see that it's not that bad. Let's use it then. Let's solve some inequalities. So we have 6 inequalities here to solve, and we need to write the solution in interval notation and graph the solution set if possible. We'll use our calculator to do the graph. All right. So definitely, hopefully you get a chance to practice with this. Definitely pause the video and try to do this on your own. You're not gonna, if you do not get the practice for these types of problems, you might suffer a little bit once you're taking an exam or a quiz. So definitely, anytime that you have the opportunity to practice this, do it. All right, let's solve these inequalities together and let's see, let's just compare answers. Okay, so according to my guidelines over here, if I have x is less than something, which is kind of what I have here for part A, then that breaks up into this compound inequality here. So then I'm going to say, okay, this breaks up into x is less than or equal to 5 and bigger than or equal to negative 5. Yeah? And now if you think about this, well, let's see, the solution set. So let me think about the number line. I guess this would be this part of graphing the solution set. This is saying it's x's that are less than or equal to 5 and bigger than or equal to negative 5. So negative 5 is over here, positive 5 is over here, and right now what I'm dealing with, I am including the endpoints because my inequalities are non-strict, and it's all the values that are between negative 5 and positive 5. Yeah, so that's what my solution set looks like. But now I'm going to use interval notation to describe this, and well, then that means bracket negative 5 to 5 bracket. Yeah, so that is the answer for this. Now, what the heck is going on here, like in terms of a graph? Let's see. So let's think about what this is asking us graphically, because we can also think about this graphically and use a calculator to solve this if we wanted to, just kind of by looking at the graph. Sorry, why can't I move my calculator? Okay, so let's see. What I could do here, let's see, let me plot some things here. So I have, let me clear this. Absolute value of x is what I want for one of my graphs. Okay, I'm gonna hit enter. And then for my other graph, I want just 5. Okay, let me graph both of these things. Okay, and so then let's think about this inequality. So right now you have the graph on the left, which is the v, and then you have the graph on the right, which is just a horizontal line. And right now this inequality saying is, when is the horizontal line above the v? That's what it means to be bigger than. So the 5 is bigger than my absolute value. So that's saying, when is the horizontal line on top of the v? Well, it looks that it's above, so the horizontal line is above v only between negative 5 and value. So right now we're thinking in the x, so only between values of x that are between negative 5 and positive 5, including negative 5 and positive 5. Yeah, that would be one way of maybe thinking about this. When is one graph on top of the other one? That's what inequalities are kind of asking us. All right, let's solve the next one. The next one's sort of similar. The next one is similar. This inequality breaks up into a compound inequality that looks like this. 3x plus 2 is less than 5 and bigger than negative 5. And now it's just a matter of solving for x. So let me subtract 2 from both sides. So that says negative 7 is less than 3x is less than 3. And then I have to divide everything by 3. So then that says negative 7/3. Just remember that if you multiply or divide by a negative, the inequality signs change. Keep that in mind. So in this case, we didn't have to divide by a negative or multiply by a negative, so that's okay. All we did is add and subtract and divide by something positive. And okay, so this is my solution set right now. Let me graph the solution set. So this solution set, I guess, would look something like this. So negative 7/3. Negative 7/3 is something like negative 2.333. So I'll say it's over here on the left. That's negative 7/3. And then 1, let's just pretend that 1 is over here. And right now we're dealing with all the values that are between negative 7/3 and 1, but not including negative 7/3 and not including 1. So it's all of these values right now. And I put these little open circles to indicate that we're not including the endpoints. So then that means that whenever I change things to interval notation, that corresponds to a parentheses. Okay, so negative 7/3, 1. That's my answer. All right, let's see, let's try the next ones. Okay, this one I was told that breaks up into 2 inequalities. One of them goes like this: 5 minus 2x is bigger than or equal to 1, or 5 minus 2x is less than or equal to negative 1. So let's see. It's kind of what we had here. So it's x is big, the absolute value of x is bigger than a. That means that, well, x is bigger than a. That's what I wrote here on the left. Or x, which in my case is this thing inside the absolute value, is less than or equal to negative a. Okay, so these are my two inequalities. And now I gotta solve each one of them. So 5 minus 2, oops, let me. So let me solve the left inequality first. I'm gonna begin by subtracting 5. So I'm gonna subtract 5 from both sides. So then that says the following: negative 2x is bigger than or equal to negative 4. So be careful with your signs. Since I have to subtract 5, that's saying 1 minus 5, and 1 minus 5 is negative 4. And now you gotta be extra careful. I'm gonna divide both sides by negative 2. And if I divide by a negative, the inequality sign is going to flip. So then I should end up with this: x is less than or equal to positive 2. Okay, so be careful with that. So here the reason why this inequality sign flipped is because in the previous step I divided by negative 2. And while negative 4 divided by negative 2, that's just positive 2. Okay, so or. Now let me solve the other inequality. Again, I'm going to begin by subtracting 5 from both sides. Well, then that would say negative 2x is less than or equal to negative 6. Why? Because negative 1 minus 5 is negative 6. And then again, I'm going to have to divide everything by negative 2. So that's going to change the inequality. So then that's going to say x is bigger than or equal to positive 3. So hopefully we agree on this. Remember that if you multiply or divide by a negative, the inequality sign changes. All right, now let's make sense of this solution. Let's graph the solution first. Just look at it graphically. So that's my number line right there. I have, let's say, 2 right there, and I have, let's say, 3 right there. And so then this inequality right here, x's that are less than or equal to 2, well, that's including 2. Oops. And it's everything to the left. And then numbers that are bigger than or equal to 3, well, that's from 3 to the right. And I am including 2 and I am including 3. And now the or just means union. So then in interval notation, the interval notation would go something like this: negative infinity to 2 with a bracket, union, bracket, 3 to positive infinity. Yeah, so that's my solution there. All right, so hopefully we're on the same page so far. If not, then just make sure that, remember that if you divide or multiply by a negative, don't forget to switch your inequalities. That's important. This next one, let's solve it. I'm going to add 5 to both sides. Okay, if I add 5 to both sides, I end up with this inequality. Absolute value of 2x minus 4 is less than negative 5. Yeah, okay. And now here we get into a situation again where things are gonna get tricky. Remember kind of what we had with this equation up here, where we had an absolute value and then an equation or an inequality and then something negative. Remember that the absolute value is always positive. That will always be positive no matter what choice of x. So over here, sorry, let my computer here load the image again. Come on, come on, come on. Technical difficulties, I apologize. There we go. Okay, so here I have something in absolute value, something inside an absolute value. Well, that will always be positive. No matter what choice of x, no matter what choice of x, it will always be positive, or maybe zero. Or maybe zero. And so then something positive or zero will never be smaller than -5. Yeah, another way to think about it is that right now, something positive on the left hand side will never be smaller than -5. So what can we say here? I guess what we can conclude here is that this has no solution. No solution. Sorry, no solution. Why? Because this part on the left hand side of my inequality will always be positive. The smallest it can be is 0. So 0 or positive. The -5, well, is negative. So no matter what choice of x I make, I always have something positive, and something positive is not less than -5. So this has no solution. So this one's kind of tricky. Be careful. This one's also kind of tricky, part E. Part E is also kind of tricky. What can I say about this one? Again, whenever you have absolute value and then an equals or an inequality and then you have a negative on the other side, pause for a second. Don't just go through the process of solving. Think about what's going on here. So now what I have here is that the left hand side is always positive no matter what choice of x. Yeah, and so then this graph will always be, since it's always positive, it will always be bigger than -4 no matter what choice of x. So this one is also kind of tricky. This one's also kind of tricky, and I guess this one ends up, we have to conclude that there's infinitely many solutions. Sorry, I apologize. I don't know what's going on with my computer. It's a little slow. So this guy has infinitely many solutions. Yeah. Let's see. How can we maybe look at these things? Well, let's think about this, guys. So remember, anytime that you end up with the absolute value of something and then you have an inequality or an equal signs and then you have something negative on the other side, you gotta pause for a second, because something, either you're gonna have no solution or infinitely many solutions. Something positive or equal to 0 can never be negative, can never be smaller than negative. So here's no solution. Now, something positive or equal to 0 is always bigger than something negative, no matter what value of x. So that's why this guy has infinitely many solutions. So yeah, these two scenarios here are kind of tricky. All right, the last one. This one's okay. This one, we're just going to treat it like a regular one. So this is going to split up into two inequalities. One of them is going to say 2x plus 1 over 3 is bigger than 5, or the other one would be 2x plus 1 over 3 is less than -5. This one we can actually solve by the regular method. Alright, and let's solve it then. Let's solve it then. Just keep in mind that if you multiply or divide by something negative, the inequality sign changes. So the first thing I'm going to do is I'm going to multiply. I'm going to solve the inequality on the left hand side first, this part on the left hand side. The steps to solve the right hand side inequality are similar. The first thing I'm going to do is multiply both sides by +3. Okay, that does not change my inequality. Okay, and then I'm going to subtract 1. Because 15 minus 1, I guess that's 14. And then I'm going to divide everything by 2. So then that's going to say x is bigger than 7. Now let me solve the other one. In the other one, I'm going to multiply both sides by 3, same thing. I'm going to subtract a 1. Because negative 15 minus 1 is negative 16. The inequality hasn't changed because we haven't divided or multiplied by a negative 1. And then the last thing I'm going to do is divide everything by 2. Okay, so then that says x is less than negative 8. Okay, so then let me think about what the solution looks as a number line. Let me look at the solution set as a number line. So I'll pretend that 7 is right there, and I'll pretend that negative 8 is over here. I'm going to have these little gaps here because right now I'm dealing with strict inequalities. And so this inequality, x is bigger than 7. Say that it's all the values to the right of 7. X's that are less than negative 8. So that's all the things left of negative 8. And the interval notation here would be negative infinity to negative 8 with a parentheses, union 7 to positive infinity. Okay, so keep these little tricky things in mind. Anytime that you have an absolute value and then an equation or an inequality and then something negative, pause for a second. It's probably the case that either you're going to have infinitely many solutions or no solutions. So be careful with that. Okay, that's it for this section. That's it for this chapter. I'll see you in chapter 4. Thank you.